Hello everyone, a very warm welcome to you all. It is great to have you all in the second webinar session of Ravana Aviation Research and Development Division. Today, the resource person of RAR&DD is Dr. Madhuri Sharon ma'am. She is a director at Walton Center of Research in Nanotechnology and Bio-Nanotechnology. She is also a visiting professor at MNIT Jaipur in India. Today's session is on CHUMBAK Mani, as described in Brihad Viman Shastra. So let us now know a little on CHUMBAK Mani. CHUMBAK Mani, which was described in Brihad Vaimanika Shastra by Maharshi Bharadwaj, is around 4000 BCE, was an ancient landmine detector which emits electrical signals to find hidden arsenal inside the ground. It can be while flying or moving about. Now let us learn more about its rediscovery by Madhuri ma'am, and we request her to start her presentation. Thank you.
Now, Viman Shastra by Maharshi Bharadwaj is a very big book. There are lots of things in it. So we have worked on CHUMBAK Mani, one special equipment that they have described, and the supporting equipments for the functioning of CHUMBAK Mani. This project was actually granted by CSIR to Professor Sharon, and I and Van Sundareshan, we both worked on the same project. Me being the director at that time, so I took the responsibility. Now, when we took the book Brihad Viman Shastra by Maharshi Bharadwaj, we realized that it has so many things in it, and we were not engineers. So we had no idea of working on designs, etc. So we were looking for something, which is more of a chemistry or physics or bio, that science part of it. And in that process, we read the whole book. And we read it, we realized that we can, carry on thousands of projects on this book. One person, Maharshi Bharadwaj, he had the knowledge of engineering, the chemistry, the physics, the bio, everything. And that was very, very surprising and very great. And that actually incited us. And we asked for money from CSIR. Usually for such things, money is not given. But Professor Sharon has been lucky, that he could manage to get it. He was in IIT at that time. So if you look at this book, there are about 21 chapters and 100 adhikarans, means sub-chapters, and which has sutras. And sutras describe them, give them the recipe of fabricating something, or how to run it and what to do, when to do, etc. All is described. The worst part is that we could not understand most of it. It was Sanskrit. My Sanskrit is okay, but it's poor. And therefore, we had been, always looking for good Sanskrit scholars who could translate it for us. And going through all the 500 sutras were not possible. So we had to select some on which we can work. Because this book was all discussing about the types of vimanas which were out of my domain of knowledge, the alloys and the metals, etc. to be used, the instruments which were incorporated or encompassed into the vimanas, then pilot when he is going to fly, what he should eat prior to flying, small details, all is given in this book, and source of fuel. So actually, we worked on some of the instruments which are used or which are placed in the Viman. And I just want to tell you that Maharshi Bharadwaj was not the only person who has written a book on Viman Shastra. And this gives an idea that Viman Shastra was not a one person's figment of imagination. There has been many people working on it. So there must have been industries or factories, whatever it is, for making Vimanas. And some of them names that I could get are Narayan Muni. He wrote Vimana Chandrika. Then Shaunak Rishi. He was one of the very, very great rishis. And Shaunak Rishi was a big rishi. And he was running a school at that time which had about 88,000 students. and he wrote the Vyama Yantra. Then there was Garg Muni, who wrote about the Kalp. Kalp is, how to explain things. Then Vajaspati Rishi, he wrote about Yan Bindu, the finer details of the Viman. Chakrayani Muni wrote Khetyani Pradipika, and Dhundinath Muni, he wrote Vyom Aksharshan Pradipika. So there were many people, apart from them also there have been many people, but some of these books are not easily available, just the names are available. This I just mentioned that it was a science and it was accepted and was being taught. Now, our report was based on Maharshi Bharadwaj from his book. Now, in 10th chapter, he describes a Guha Garbh Darshan Yantra. Guha means hidden, something which is not open. Garbh means inside the stomach or underground. Darshan means detection, and Yantra is an equipment. So this is about an equipment which detects while flying if there is anything, hidden or landmine type of thing under the earth, and that they can detect while flying so that they don't land there. So this equipment has many parts in it, and we selected 3 parts of this equipment. One was Panchaloha, and it is described in 4 sutras. Another Chumbak Mani is also described in 4 sutras, and Pargrandhik Drav, that is actually electrolyte, which is described very much in detail in 5 sutras, 42 to 46. So we selected these 3 to make. Actually, there was one more thing, which was converting all these informations into images. But we couldn't work on that. This work itself took us about 5 years to complete. Now, let me tell you what is Panchaloha, what is Panth. As I told you, instrument works like a photoelectrochemical cell where solar energy is converted to electrical energy. We'll go about this in detail. Now, Guha Garbha Darshan Yantra. Let's see. As I said, first ingredient and the main ingredient was the Chumbak Mani. It emits a kind of electrical signal when it is exposed to the solar radiation. Then Pargandhik Drav is a redox type of solution, and this solution, this is a redox type of solution, or you can call it electrolyte. And in this electrolyte, Chumbak Mani is dipped in presence of sunlight, and then it works. And Panchaloha is prepared to create ohmic contact between Chumbak Mani and so that it can allow electrical signal to be sent. So it's just like a cell that they made. And then whatever the information comes, that as I have already told you, that this is generating some kind of image, and that image they used to see. This image type part of work we have not done. We would have loved to do that, or if I live any longer, I would love to do that. Now, there are, as I said, Chumbak Mani is described in 4 shlokas. One of the shloka gives the name of ingredients that is used. This was very difficult part in all 3 of them. So here I am giving you the from those 4 or 5 shlokas, I am giving you the shlokas which describes the ingredient. And these ingredients, it was very difficult to, get them really converted into what our knowledge of chemicals are there, or the plant material that they mentioned and plants that we know today. They were very different. So we had to consult many people, and we are obliged to many people, who helped us in making this. This is the Chumbak Mani. That is when we prepared it. You can see all these shiny dots. This is the crystallized Chumbak Mani. Okay, so as I said, our work is laboratory work, and we started preparing Chumbak Mani. And first step was that we took very equal amount. Here I have not mentioned, but I mean about 10 grams of each. Okay, it was nicely washed, dried and grinded. And then we put it in a, so you can see we put this all 10 grams of each into an alumina crucible. We didn't use others, alumina crucible we used. And these are the ingredients. Which kapal was buffalo's head bones. Actually, I should have written bone. This is a plant. People is a plant. Sand is sand. Mercury, copper, borax, ivory, all you know. And this mixture was crystallized in alumina in a muffle furnace. So you can see this is the muffle furnace. Now we didn't know because they don't mention the temperature at up to which degrees we should heat. What they said, you should heat till you get the netramilan. And what is netramilan? That is, this whole thing starts becoming liquid, and top of liquid there will be some blue dancing flames that will appear. So we realized that to get netramilan, 1250 degrees centigrade was needed, and that was the, see, it was very difficult because many things what we know today, how we are taught today, at that time was very different. So they were describing the temperature when you start receiving netramilan, and we realized that that is 1250 degrees centigrade. And then this liquid was poured into flat container that you saw just now, and it was cooled. So there were two phases. There were some tiny, shiny crystals, and there about 25% of the total was that crystal, and other was non-magnetic material, and they could be easily separated. But there are problems which, as I have already told you, exact meaning and name and what they mean, what we have to do. So many experiments that was done initially were wrong, and then we had to re-understand it and then repeat the experiment. And getting a crucible in which we can do it, because usually we go for high temperature platinum crucible. But when this mixture became molten, it started reacting with the crucible, and that was very dangerous. Similarly, measuring the temperature, because thermocouple inside the crucible was very difficult, and that thermocouple also reacted with the liquid. So we could not put that, and that's how the netramilan we concentrated on, and we found that that is the right place, the thing where we can understand the temperature. Now then we have to prepare the paragrandik drav. Drav means liquid, and actually paragrandik drav is an electrolyte. So that we have prepared. That you can see here, we didn't have to go for alumina crucible. And we had ingredients. Here also the ingredients that we had, we took in equal amounts, and as I said, we were taking 10 grams every time so that we have a standard that we don't deviate very much from that. So we took these equipments. It was nicely grinded and boiled in ordinary, a big flask, and boiling temperature was all right to do it in a glass beaker, so it was easy, and it was filtered. And the filtrate was yellowish green. And when we the moment we bring it to the room light, it used to turn very dark. So as soon as we filter, we used to store it in the dark. And while filtering also, we would cover it with the black paper. And this liquid was a paragrandik drav. This liquid was the electrolyte. Now, panchaloha, that's another ingredient that we needed. And panchaloha was, again, we had to take equal amount. And here also, Sonamaki, copper, deer's horn, Vishwa Rajak, these were the ingredients which needed alumina crucible. We could not do it in ordinary crucibles or in glasses, although we didn't go very high to the temperature, but for a longer period. And when it was heated, I mean, it's so surprising, even the, horn and the bones, etc., it becomes liquid. in presence of all these things. And otherwise, making, if you start heating a bone or a horn of any animal, it doesn't become liquid. But the ingredients, somehow the other acted as a catalyst to melt it. And after cooling, shining metal was obtained. So this metal was taken as Panchaloha, that sheet of that metal. Now these things we have Chumbak Mani, Panchaloha, Pargranthic Drav. We had to assemble it to make a Guha Garbha Darshan Yantra. So assembly involved, what happened? We had to first collect all the crystals of Chumbak Mani and make a pellet of it. So pressed, and then cut it into square centimeter pieces. Actually, it was made in square centimeter pieces. Square centimeter Chumbak Mani crystals were pressed and prepared. And then on one side of Chumbak Mani, Panchaloha was soldered using a copper wire. And Panchaloha was, with the side which was open, that was painted with insulating paint, because when we dip it into the Pargandhik Drava, we didn't want to it to come in contact with that, with the liquid. And platinum electrode was used as a counter electrode. So I'll just show you this. So this assembly, as you can see here, it was dipped. It's not very clear. I'll show you one another diagram. Maybe it will show you and give you the details. So the Chumbak Mani crystals attached to Panchaloha was dipped in Pargranthic Drav, and there was a problem, because we didn't know what is the band gap or the detailed information about Pargranthic Drav, because we have never come across any such electrolyte. So therefore, we did work with Chumbak Mani using some known electrolytes. So we used one of Fe3, Fe2 nitrate, cerium 4 and 3, ferroferric cyanide, and potassium iodide and iodine. So these also we studied. So this plus Pargranthic, this not plus or this. So we had 1, 2, 3, 4 and 5 different types of electrolyte just to compare our results with them. So then we exposed it to solar radiation and the potential was measured. Here you can see in a simpler way, this is our Chumbak Mani and this is the insulating paint on it, and its Chumbak Mani is on Panchaloha. Sun is there, this power source that is given to the ammeter, and platinum wire as a counter electrode. So this is the schematic diagram of what I explained earlier. Then comes that what we have prepared, what are they finally? What are the contents, how they behave, what's their morphology, what is their surface chemistry, what is their thermal behavior, etc. So we started with first atomic absorption of Chumbak Mani and to know what are the metals present into them. So we took the Chumbak Mani, dissolved it into HNO3. It was not fully soluble. That was the problem. It did dissolve, but solubility was very low. But it showed presence of copper, manganese, silicon, and iron. These metals were present in Chumbak Mani, which was shiny. But none of atomic absorption could not tell us that what was the concentration or the percentage, because Chumbak Mani didn't completely dissolve in it. Some part of it didn't dissolve and it remained at the bottom. Then we did XPS analysis, but this time we did the analysis of the plate. That was the dissolved Chumbak Mani, this was plate. But this also showed the same results, copper, manganese, silicon, and iron. And this also had the same problem, because we couldn't. The problem remains now that things we don't know, and we aren't getting very good Sanskrit scholars to translate them to our full understanding. So we did the XRD, of course, using cobalt or iron as target and XRD data. We used as prepared CHUMBAK money, and we also used annealed. We annealed it at 900 degrees centigrade just to see if it can be purified slightly. And you can see D values at 100, 50%, 75%, and the peak at 7. You can see there is not much difference in 100, and in 50% there is no difference at all. But at 75%, peak is absent, and that is after annealing. So annealing did something. I don't know what it did. We didn't get the result. And JSPDS data that we tried to compare with it, it did not match with any known oxide or metal, because at 900 it might have formed the oxides. But what it is, that we could not find out. Then we did the differential thermal analysis and thermogravimetric analysis, and the results are very interesting. DTA shows phase transition at 410 and 460 degrees. This is DTA data. Okay. And because CHUMBAK money structure was not established, we made it, but it's not very well established structure. So it was very difficult to analyze the phases present at these transition. What are these phases? That simultaneously TGA was also done, and that was another interesting thing, that up to the room temperature and up to it was always going down. There was loss in weight. That means it was breaking down from at this temperature. And this is due to oxidation of the material, as we said earlier. Since no change was observed in XRD of sample, even when they were heated at 900 degrees centigrade, so then it becomes more difficult how to explain the loss in weight. Had there been any change here? So that means whatever we got and whatever was there, and even if you anneal it, it doesn't alter the characteristics. This ESR result also was done to measure the line width, and as you can see with the temperature, and here we use 77 to 569 K, and as you can see, line width started decreasing with increase in temperature. That's the other way around I've written. Okay, line width is increasing with increasing temperature. So this was what we earned. But this actually, I must say, ESR, we have been confused even when we did it, and we didn't get any good result with it. But it had very large line width that you can see. Okay. But magnetic field on the G effective values obtained are these. So it had magnetic property that we always said that it was magnetic in nature. Photoresistance, that was an interesting point. That so all the possible analysis that we did, one was the resistance of 1 square centimeter plate of CHUMBAK money. It was measured using platinum contacts with the help of silver paint by a multimeter. And for every wavelength of light we measured, and it was found that with increase in wavelength, there was a decrease in surface resistance of CHUMBAK money, as you can see. So hence it can be said that this material may be useful as light detector, because you see it is responding to different wavelengths in a very, very set pattern. So then this is electrical resistance, how we measured. So this was our setup. You can see this is our platinum plate, and the central black one is our CHUMBAK money, and then it is attached. It is kept in a quartz tube. This is a quartz tube, and platinum wire here and here, they are there. And the thermocouple wire is your this, but as I told you, it was difficult to for thermocouple to perform, and it was done under the vacuum. So this is the tube to create the vacuum. And DC electrical resistance was measured at room temperature to 750 using multimeters, and temperature was measured with ion constant thermocouple that I have told you here. So that was electrical resistance at various temperatures. This was very interesting character, very interesting. Up to 400 degrees, you can see it is increasing and it shows metallic behavior. And at higher temperature, it starts showing semiconducting property with a transition at 380 degrees, 400 to 380 degrees centigrade. So this was very interesting part of this when we came to electrical resistance. So we have thought of exploring it, whether it can be used as thermosensor or not, or resistance decreases even to 0 ohms. So chances are that it may show some property like superconductivity. We have to work on this. So this we have not done. And photoelectric property, this was the last thing that we wanted to do and we studied. And so you can see in cerium, photocurrent and photopotential, we measured them, and you can see these were the data. But when we used Pargandhik dove as the electrolyte, we got the highest photocurrent and photopotential. So both were highest. So this electrolyte is much better than those that we know. And moreover, it suggests that the band position, it should be such that the redox potential of our electrolyte Pargandhik must be between conduction valence band of the Chumbak money. See, there are many things which needs still to be done. So in short, this is how we are measuring it. And in short, I can say this is the whole setup after making it. And Chumbak money is made by contemporary flux techniques. Nowadays, we use flux technique for making. That is what this technique, when we came to know, was a flux technique. And this flux was very reactive and dissolves oxides of iron, even sand it dissolves, silicon and sand it dissolves. So it can be used, or it will be useful for melting high melting point metals, this material. The other is that getting the right temperature at which we start getting the Chumbak money of 1250 was also very interesting finding, because we never knew how much we have to heat it in a furnace. Many experiments went wrong, and finally we stuck to the Netra Milan and we got the result. As I said, the best is that it is metallic up to 400 degrees centigrade, and after that it becomes semiconducting, and it even comes down to 0 resistance, and therefore, as we mentioned, that it can be used as a superconductor, or worked on it at least. And Pargandhik dove is a light sensitive electrolyte, and Guha Garbha Darshan Yantra, this whole combination is a very good combination of converting solar energy into electrical energy. So it is a photoelectrochemical cell. The whole Guha Garbha Darshan Yantra is a photoelectrochemical cell. We acknowledge CSIR for providing grant. It was for 3 years. The work was not completed. It was extended for 2 years. Usually, India government doesn't give money for such ancient science work, but especially when we got it. So anyway, we have been very lucky we got this, and I still don't know who was the head person in granting it in the meeting, but whoever he was, I must thank him, because that was a very big decision by him to give money for this work. Well, and here I stop my presentation, because this is all, it's a laboratory work, although it took very long time, but this work has given us an idea that even small details of this as I wrote, limitless possibility in this book is there, can be looked into it, and I can create thousands of PhD students each giving one sutra and working on it. It's such a good book. Others books I have not read. So I wish to thank you for your very quiet hearing. I don't know how much it went through you. But anyway, but if you have any question, I would love to answer if I can. Okay? So thank you very much.
I gratefully thank Madhuri ma'am for such an inspiring lecture, and also thank Captain Harsha sir for making this happen. This platform has been established by Captain Harsha sir. The RAR&DD division is a special division of Ravana Aviation, which was established in year 2012. Thank you all for staying on the platform, and I hope the lecture helps the researchers and the curious minds alike. Any further questions, you can email us. The email IDs are presented. And thank you all once again. We will be waiting for you to join our next lectures and workshops. Have a great day.